So this is 13.3, evaluate the trig functions at any angle. And the refresher on this is going over the patterns because this unit is built, and trig is built on these patterns. You know, I wish that there was more time allotted in geometry to get these things down, just ironed out. 45, 45, 90 pattern, of course angles matter, is XXX root 2. And usually when I teach this particular section, I focus my attention on this variation, 1, 1, root 2. That's the big one for this section. Okay, it's not a circle section, that's tomorrow, but this is the big one for this section. And the 30, 60, 90 patterns X, 2X, X root 3, with the short leg X opposite of 30 degrees and the long leg X root 3 opposite of 60. And this particular section, I like to use the numbers 1, 2, and root 3. And you know, some of you guys are memorizing like you're supposed to, and a lot of you just not, because it's the end of the year, and you're like, screw this, I don't want to learn it. Whatever, it's your grade, man. 30 degrees is pi over 6, 60 is pi over 3, this should be a refresher, 45 is pi over 4, and 90 is pi over 2. Those are big ones, okay? They really are. So the concept, one of the key concepts here is called a reference angle, and actually it's actually in your notes twice because it's that big of a deal. The reference angle is an angle formed with the nearest x-axis. Reference angles also possess, I got too many S's on that thing, don't I? Possess the exact same trig ratios as the actual angle. All right, so your examples here, find the reference angle for a 60-degree angle. Well, this one's kind of one of those silly ones, okay? You draw a 60-degree angle, and you discover that 60 degrees is the reference angle. Now, if an angle lies in the first quadrant, you don't need a reference angle. It literally is. It is the reference angle because it is the angle formed with, if I can read, the x-axis, okay? All right, 210 is up next, and kids, you can't sit here and ask why. Like, some kids always want the reference angle to be with the y-axis. This is the definition of how it works, okay? So 210 degrees, we start here, and we rotate 180, and then we rotate a last little bit of rotation of 30 degrees. This 30 degrees right here is the angle that's formed with the x-axis. Hey, hold on, let me pause this video real quick. All right, sorry for the interruption. I got interrupted by my wife and a kid who want to know if they can get their stuff out of the room. Interesting. All right, so C is -5 pi over 4. You're going to have to convert that to degrees. You know, remember that pi is worth 180, right? Did you have fun today? Yeah. You did?
It wasn't as bad as I was expecting.
I didn't figure it would be. Did you get a job?
No, but I got a paper from one of the ladies up there who ran a senior health thing. She said if I wanted to, I could call them.
And you should.
I'm gonna. I like the elderly.
I'm glad you like somebody. See you, Taylor. All right, so where were we? Oh, yeah, we're cleaning this up. Okay, so this is going to be -225 degrees. You know, that's what it is. I know that because I know what 5 pi over 4 is, but that's just what it is. And if you don't believe me, because, you know, I just make stuff up all the time, there you go. -225. Hopefully you guys have improved on this since your last test. A negative angle rotates like a clock, 180 degrees and then 45 more, because we add in that 180 and we still have a -45 degrees of rotation. And it looks like this. Okay, now go back to your definition. The angle formed with the x-axis is the reference angle. So that's going to be this piece right here, which was 45 degrees. And it's not negative, it's just 45 degrees. Reference angles are not negative, okay? It's just a 45-degree reference angle. All right, so there's going over reference angles. I know some kids struggle with this. Now here's where we start getting to use this. Let -4,3 be a point on the terminal side of angle theta. And remember, all angles start on the positive x-axis and then they rotate to a terminal side. So -4,3 would be back 4 and up 3. So this angle rotates to right there. And I think the hard part for kids to get is that this is the angle, okay? I don't think I've specified it yet, but we use prime notation. So for this guy, the reference angle is actually called theta prime. It's got a little prime symbol. I know that's kind of hard to see. But anyways, I'm just going to start over on that diagram. It got so crooked. All right, so we started here, and we rotated to -4, 3. And that's where we stopped. Now the whole angle we would have called theta. We're going to call this one theta prime. And we're going to imagine a triangle. It's not really there, by the way. We're just going to imagine it. So theta prime is the reference angle because it's formed with the x-axis. And to get to this point, we went back 4 and up 3. Now, every single kid is supposed to have memorized the 3, 4, 5 right pattern. That is a 3, 4, 5 right triangle. Evaluate the 6 trig functions of theta, and we're going to do that by using theta prime because what's our note say? Reference angles possess the exact same trig ratios as the actual angle. All right, so let's go through them here. We have the sine of theta, and that's going to be opposite over hypotenuse, and I'm here. This is my opposite, 3. 5 is my hypotenuse, it's 3/5. The cosine of theta, that's a over h. Adjacent is -4, and the hypotenuse is 5. I'm going to point out something here in just a second. Tangent of theta is opposite over adjacent. So opposite is 3, adjacent's -4. So 3 over 4, and the 4 is negative. We'll move the negative out to the numerator. And then we get to do the reciprocals. And you can really do this using, you know, the ho, ha, AO thing if you want. I just like to flip numbers. Cosecant is reciprocal of sine. If sine's 3/5, cosecant's 5/3. Secant is the reciprocal of cosine. If cosine's -4/5, this guy's -5/4. And then you have cotangent, which is the reciprocal of tangent. And if tangent's -3/4, cotangent's -4/3. Just flip them. And this is coming in these section notes here, but ASTC. This triangle was in quadrant 2. The only thing that was supposed to be positive was sine and cosecant. And look, sine is positive, cosecant's positive. Everything else was negative. Cosine was negative, secant was negative. Tangent was negative, cotangent was negative. That's the way you check yourself. All right, let theta be an angle whose terminal side intersects the point -2, -5. So this angle is going to terminate in quadrant 4. It's going to go back 2 and down 1, 2, 3, 4, 5. It's going to be right here. And again, the angle would look like this. I thought I changed colors. The angle, okay, third time's a try. The angle would look like this, and it would rotate clockwise. But the angle that I want, which I'll just call theta prime, is formed with the x-axis. And I went back 2 and I went down 5. Now, a really, really old theorem gets you the hypotenuse, which you'll need. So it's going to be a -2 squared plus a -5 squared, and that equals c squared. And the hypotenuse is always positive. That has to do with what we call vectors and stuff, but it's always positive. And Pythagorean theorem makes it such. You never make the hypotenuse negative, even if you want it to be negative, it's not. So we have 4 here and 25. That's going to give me root 29 is c when everything's said and done. And so we get one of these that's kind of ugly, okay? So it'll take a minute or two to go through the 6 trig ratios for this one. If we're here, this guy is the adjacent side. This guy is the opposite side, and that's always the biggie, and this would be the hypotenuse. And again, remember that the sine of any angle is opposite over hypotenuse. So -5 over root 29. And here's the thing that kids don't like, because wait, there's more. You have to multiply top and bottom by root 29. And you get -5 roots of 29 sitting pretty over 29. cosine of any angle is adjacent over hypotenuse, and adjacent is the -2, and the hypotenuse is still root 29. And again, but wait, there's more. We multiply by root 29 over root 29 to change the number, not change the number's appearance, not its value. Because even if you put makeup on something, underneath that makeup, it's still kind of ugly. And you get that. And lastly, we have the tangent of any angle, and the tangent is defined to be opposite over adjacent. So opposite is a -5, adjacent is a -2, and you should be cleaning that up because you know what a negative over a negative is. It is a positive. And again, I like to do reciprocals, but it doesn't really matter. So on the last one I did reciprocals, on this one I'll just do this. We know that sine is a hoe, we've talked about that. It's root 29 over the opposite side of 5, put the negative up top. We know that not cosine, but secant is a funny guy. It's ha. Hypotenuse is root 29. Adjacent is a 2. The negative symbol belongs in the numerator. And we know that cotangent says AO because it's excited. So it's -2 over -5, which is going to be 2/5. Moving forward with our lives. The concept of coterminal angles, which you've done before, I just put in here again for no good reason, I don't know. But for example, if you have theta being 765, you would plus or minus 360. So 765 plus 360 degrees is 1125. Yes, 1125 degrees. 765 minus 360 is 405 degrees. You can make things smaller. You could even take away 360 again and get 45 degrees. The reason I'm talking about this is because it might make sense to do these things so that you don't have to graph something as complicated. And for our pi's over 6's, we would plus or minus twice pi. And I'm not going to waste, well, I guess I should. -33 pi over 6 plus 2 pi. That would be -33 pi over 6 plus 12 pi over 6, which would be -21 pi over 6. And I could just keep adding 12 pi over 6 until I get something that's easier to work with. So -21 and 12 I think is 9. That's 9 pi over 6. Hey, that reduces 3 pi over 2, which is on the unit circle. That would be what I'd want to work with, right? Yes. And again, here's the key concept of the reference angles. I thought it was so important that I put it in your notes twice. The angle that an angle's terminal side forms with the x-axis. Reference angles always have the same trig ratios as the given angle. They are denoted with the prime symbol, example, theta prime. Or maybe alpha, or maybe beta. Here, we'll let this one be beta. This is beta equals 330, and beta equals -254. So I want to find the reference angle, so I'm going to draw beta. Beta is a 330-degree reference angle, or 330-degree angle, and it would rotate 330 degrees through quadrants 1, 2, 3, and part of 4. Now, the reference angle here is what's left. It's what it takes to finish the circle, because that's what gets you to the x-axis. And a lot of kids are like, oh, so you just think about what it takes to rotate. I don't want to talk about what other kids do and say because they never get the crap right. Just trust Milbrath. Do it this way. Think about what little bit of rotation it takes to get you to the x-axis. And it takes 30 degrees of rotation to get to the closest x-axis. That's kind of the definition. Forms with the x-axis. -254 is going to rotate like a clock, right? It's negative. We're going to rotate 180 degrees. Okay, so I'm going to add that back. 74 degrees of negative rotation, which is going to take you almost to the y-axis, but not quite. And that last little bit of rotation was the reference angle. The reference angle is 74. Now, right now, I haven't taught you how to work with those odd angles, but I will, obviously. I will. And here we have evaluate using reference angles. I don't know why, but I've never fixed these notes. Let's make this the cosine of -420 degrees. And let's make this the cosecant of 15 pi over 4. Okay? And this may differ from whatever I do in class, but you got to have a trig function to evaluate. It was probably originally saying evaluate the 6 trig ratios, but ain't nobody got time for that. Now, I'm going to use coterminality to make my life easier. I'm gonna add 360 degrees, and I'm gonna get negative 60, which is something really easy to graph, right? That rotates like a clock, and it's gonna rotate 60 degrees. And hey, that angle is formed with the x-axis. So sweet, it's the reference angle, okay? I'm gonna triangle this out based off of this one. 1, 2, root 3. Now, direction is extremely important. Opposite of a 60 degree is a root 3, but it's falling. Adjacent to the 60 is a 1. See how the 1's next to 60? And it's running right, so it's positive. And hypotenuse, are always positive. So, I want to do the cosine of this angle. So even though I change the numerical value of the angle, I'm still just using this reference angle. Cosine is, remember, ah. So adjacent is a 1, hypotenuse is a 2. Pretty cool, huh? Now, if I would have added another 360, I would have been at 300 degrees. So I'm trying to tie into what you learned on that circle. 300 degrees is about, not there, 300 degrees is about right here. And the ordered pair at 300 degrees is 1/2 negative root 3 over 2. I want you to notice that the x value is cosine. There's a big tie-in going on here, all right? Up next for us is 15 pi over 4. Okay, and that's cosecant, by the way. That is cosecant. Cosecant's a hoe, right? Remember, hypotenuse over opposite. So you're going to have to convert that into degrees. You should know that pi is worth 180 by now. If you don't, God bless your soul. And it's a big angle. Whoops, I don't know why I divided by 45. It's divided by 4. It's a big angle. 2,700 divided by 4, Benjamin. 675 degrees. And I have no desire to graph 675 degrees. What I'm going to do is I'm going to take away 360. And that's what I'm going to graph. I'm going to graph a 315 degree angle. And a 315 degree angle again starts on the first quadrant and it rotates 90, 180, 270 and it stops about right there. Also something you would know if you understood the unit circle. So memorize the unit circle because it will pay dividends. The reference angle is the 45 degrees it takes to get to the closest x-axis and it measures 45. That was 315. Then I'm going to fill out the 45, 45, 90 pattern, and I suggest you do it with this, 1, 1, root 2. So opposite of a 45 degree angle is an understood 1, it wasn't actually there. Adjacent is 1. Now this guy is falling. The hypotenuse is root 2. And I said I was going to do cosecant. And by the way, this is as good a place as I need to re-mention this, ASTC. The only thing that's supposed to be positive in quadrant 4 is cosine and secant are positive. My answer had best be negative. It had best be negative. Now, we talk about the cosecant of 15 pi over 4. Notice I left that the same in the trig function. I'm using the reference angle. Cosecant's a hoe. Root 2 over negative 1. And don't you leave an answer like that. That's just negative root 2. That's the cosecant of 15 pi over 4. Moving forward with our lives, the all schools tortured children. You know, there's a handful of you. Well, there's more than a handful. There's about 10 of you that I'm not sure you know how to breathe. But most of you have got this down. Like Dalton Dean, this is the only thing he's struggling with. The A stands for all trig ratios are positive. Again, in class, I use a different acronym. Something I can't say on YouTube. In quadrant 2, sine and cosecant are positive. Now, by the way, if these are the only things that are positive, everything else has to be negative. In quadrant 3, tangent and cotangent, it's reciprocal, are, guess what, positive. And lastly, in quadrant 4, there's a C, and a lot of kids want that to be cotangent or cosecant, but it's cosine. cosine and its reciprocal secant are positive. So it lets you know a ratio's sign. That's what it lets you know. So moving forward, find A, the tangent of negative 240 degrees, and B, the cosecant of 17 pi over 6. And this is the last thing that's in your notes. Tangent of negative 240 degrees, that angle will rotate. And well, by the way, one thing you could do is just add 360. That's the tangent of 120. Make the angle positive. You can rotate 120 degrees. You don't have to do that, but you can. And the reference angle is what it takes to get to the x-axis, which is 60 degrees. Triangle it out. Again, 30, 60, 90 pattern. It's 1, 2, root 3. Opposite of 60 is a root 3. Hypotenuse is 2. And this is a 1, but it's running left, so it's negative. Now, I'm going to remind you of ASTC. Sine. I want tangent. The answer is going to be negative. You need to get that in your head. It's negative, 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 negative. Okay? But anywho, I'm doing tangent, and I know that tangent is opposite over adjacent. So opposite is a root 3, adjacent is negative 1. So it turns out that the tangent of negative 240 degrees is going to be just root 3 over negative 1, which is negative root 3. I always get a kick out of it when I start testing kids and they miss these problems. And it just blows my mind. Like here I am, I'm doing this by hand. All right, tangent negative 240 is that. Guess what negative root 3 is? It's the same thing, kids. This stuff ain't hard. Anywho, cosecant of 17 pi over 6. Now 17 pi over 6 is going to be 17 times 30, which is 510 degrees. But anyways, 510 degrees, which I don't want to work with. I'm going to take away 360. Find that coterminal angle. It's equivalent to a 150 degree angle, which would rotate to about right there, right? All right, cool. What's the reference? How many degrees to get to the nearest x-axis? The answer to that question is 30 degrees. Keep changing colors, but nothing's happening. Opposite of a 30 is a 1. Adjacent to a 30 is root 3, but direction is extremely important. Hypotenuse is 2. And then we just do cosecant. Again, cosecant is a whole. Hypotenuse over opposite. So it turns out that this thing's cosecant. The cosecant of 17 pi over 6, and again, that's a whole. Hypotenuse is 2, opposite of 1 is 2. And that is the 13-3 trig ratios of any angles. I'm sure you enjoyed the lesson. You probably didn't. The one tomorrow's got the unit circle on it.